Good day, I am Kim Ivan G. Velandres, and today we will discuss isometries. Patterns are geometric arrangements of shapes, colors, or other elements that repeat in a predictable way. Isometries are transformations of the plane that preserve distances between points such as translations, rotations, reflections, and glide reflections. Isometries can be used to create and transform patterns. Examples of patterns and isometries include translation symmetry. A pattern has a translation symmetry if it can be translated, moved in a particular direction without changing its appearance. For example, a brick wall has translation symmetry because each brick is identical and the pattern is repeated in a regular way, with each brick being translated by a fixed distance in a particular direction. The same can be seen in many other examples such as tile floors, wallpaper patterns, and chevron stripes. Rotational symmetry. A pattern has rotational symmetry if it looks the same after being rotated by a certain angle around a fixed point. For example, a square has a rotational symmetry of order 4 because it looks the same after being rotated by 90 degrees around its center. Similarly, a circle has rotational symmetry of infinite order because it looks the same after being rotated by any angle around its center. Other examples of shapes with rotational symmetry include regular polygons, stars, and snowflakes. Next is reflection symmetry. A pattern has reflection symmetry if it looks the same after being reflected across a line. The letter H, for instance, exhibits reflection symmetry along a vertical line that passes through its center. A butterfly's wing pattern displays reflection symmetry on a line that runs through its body. Other examples of reflection symmetry include crystals, leaves, and flowers. Next are glide reflection symmetry. If a pattern remains the same after being reflected across a line and subsequently translated or moved in a specific direction perpendicular to the line, it possesses glide reflection symmetry, due to the fact that the translation entails sliding the pattern down the line of reflection. This sort of symmetry is occasionally referred to as sliding symmetry. The zebra pattern stripe is an illustration of glide reflection symmetry. Next is tessellation symmetry. If a pattern can be repeated regularly to fill a plane entirely without any gaps or overlaps, it satisfies tessellation symmetry. Similar to puzzle pieces, tessellation are construction from identical forms that fit together in predictable patterns. The honeycomb pattern of a beehive, the tiling patterns in Islamic art, and the regular grids of graph paper are examples of tessellations. Understanding symmetry is important in many areas of math and science, including geometry, physics, and chemistry. Symmetry can be used to understand the properties of objects, predict their behavior, and design new materials and structures.